Hello guys, in this video we are going to discuss the solution of the problem number of subarrays with maximum values in given range. So let us understand the problem statement. So the problem statement says that we are given an array of n elements and an L and R. Print the number of subarrays such that the value of maximum array element in that subarray is at least L and at most R. So let us understand the problem statement. What the problem statement says is that we are given an array of, let's say, n integers, and we are given an L and R, right? Now what we need to do is that we need to find the number of subarrays such that the maximum value of that particular subarray lies between L and R, right? So here L and R are inclusive. Okay, so let me just explain it a bit further. So let us understand the problem statement. So let's say an array is given to us and the array contains elements such as 2, 0, 11, 3 and 0. So these are the elements which array contains. Apart from this, an L is given to us which is 1 and R is given to us which is 10. Okay, so given an array A, and let us say the size of the array is 5 here. So the first thing we need to understand is, given an array A of size n, the number of subarrays, right? So the number of subarray is given by the equation which is equals to, if n is the size of the array, then n equals to n plus 1 by 2. Okay, so in this particular case there will be 5 into 6 by 2, which is equals to 15 such subarrays. So of these 15 such subarrays, we have to see what is the maximum value of that particular subarray. So for instance, subarrays, if we list it down, so I'm not going to write all the subarrays, but let's just take few subarrays to understand our point. So one such subarray S1, let us say, could be 2, another could be 2 and 0, and another could be 2, 0 and 11. And let's take one more subarray, which is, so I'm sorry, this is S1, right? This is S2, right? S3, okay, and this is S4. Another will be only 0, right? So of these subarrays, what is the maximum element? What is the maximum value of S1? So the maximum value is 2 here. What is the maximum value of S2? The maximum is 2. What is the maximum over here? It is 11, right, for S3. And what is the maximum value of S4? It is 4, right? So once we have identified all the maximum value of that particular subarray, let us see if the maximum value lies within the range which is given by this, right? So the maximum value has to be less than or equals to 10 and greater than or equals to 1. So let me just write it down. The max should belongs to 1 to 11, 1 to 10 inclusive, 1 and 10 inclusive. Okay, so let us see. So clearly this is a valid subarray, right? So this is a valid subarray. Let me just highlight it by this. So this is a valid subarray. 2 is the maximum and 2 belongs between 1 and 10. Similarly, this again is a valid subarray, right? 4 is also a valid subarray. So this is also a valid subarray. All right. How about 11? This particular. This is not a valid subarray, right? Right, this is not a valid subarray because 11 is the maximum value, maximum element of this subarray, and 11 does not belong in this range. Okay, so what the problem statement says is that you generate all these 15 subarrays and you check and you compute all the maximum element of these subarrays and check if it is within this particular range. If it is in this range, then that is a valid subarray, and if it is not in that range, then it is not a valid subarray. And towards the end of it, we need to count the number of valid subarrays and return its sum. Okay, sorry, not its sum, just return the number of valid subarrays. Okay, so that's about the problem statement. Now let us look at the solution for this. So let me first discuss the brute force solution. So as you can see, the brute force solution is pretty simple. And in the brute force solution, what we need to do is basically we need to generate all subarrays, right? So we will generate all subarrays. Okay, and let us say it is there in the set S. So for each subarrays in set S, compute maximum of, let us say, let me just write it of X, where X belongs to S, right? And this we have to do it for all X belonging to S. All right, so for all these, so basically this simply, step 2 simply says that for all the subarrays which is there in the set S, compute the maximum value. Okay, now in the third step we will say if, and let's say the maximum is represented here by M1, okay, or Mi. All right, if Mi is less than equals to R, okay, and Mi is greater than or equals to L, then in such case count equals to count plus 1, and the initial value of count is 1, and count is basically the number of valid subarrays. All right, and in the final step we will return count. Okay, so that's the brute force solution. Now let us analyze the running time complexity. So the running time complexity of the brute force solution will be governed by this step alone. See, this will take a order of n into number of subsets, right, into number of subsets. But this step 1 is where is the costliest operation, because it requires generation of all subarrays, and the total number of subarrays, as we know, is given by the formula n equals to n plus 1 by 2. So the running time complexity is n squared. Okay, so for the brute force solution, the running time complexity is n squared. And since we are not using any auxiliary space, so the auxiliary space we need is constant, which is represented by order of 1. All right, so that's about the brute force solution. Now let's look into the optimal solution. Optimal solution. Okay, so let's see how to work with the optimal solution. So to understand the optimal solution, let's take our array A, which consists of elements 2, 0, 11, 3 and 0, right? And L is given to us as 1 and R is given to us as 10. Okay, so what we need to do is that what we are going to do in the optimal solution is basically we will count the number of subarrays, count the number of subarrays whose maximum is less than or equals to R. Okay, so we will count the number of such subarrays where the maximum is less than or equals to R. So, and let us say this particular is our step 1, and this is represented, or this is the value of this particular step is stored into a variable which is R subarrays. Okay, let me just see it, R subarray. So R subarray contains the number of subarrays where the maximum is less than or equals to R. Similarly, we will count the number of subarrays whose minimum, whose maximum is less than L. Please note, here I am using less than or equals to R, whereas here I am just using less than L. Okay, whose maximum is less than L. All right, and let us say this is something which is stored in the variable L sub array. So what will be our answer? Well, our answer is basically, let me just use it, answer is basically R subarray minus L subarray. Okay. So if you look at this particular step 1, okay, let me use a different thing here. So if you look at step 1 will exclude all the subarrays where element or where the maximum value is greater than R, right? So the first thing it does is that it excludes, let me just write it down here, excludes all subarray whose max is greater than R, right? So that's the first thing it does. Have a look on this particular equation. Because of this, all the subarrays where the maximum is greater than R will be excluded. But it includes, and this is something we have to understand, this includes all subarrays where the maximum is less than L, right? Includes all subarray whose maximum is less than L, right? But our objective is to find it between this particular range. So since step 1 includes all the subarrays whose maximum is less than L as well, that is why in step 2 we are counting the number of subarrays whose maximum is less than L, right? Once we have that, then we will deduct it from the R subarray, and towards the end we will get our answer. Okay, so that's about the conceptual part of it. Let us go over with the help of an example in order to solidify our understanding. So to solidify our understanding, let us go over an example. So in our example, the array contains element. How many elements does it contains? Well, 5, and the elements are 2, 0, 11, 3 and 0. So these were the elements, and the value of L was 1 and the value of R was 10. Okay, so remember from our discussion, we want to compute R subarray and L subarray. So let us first look at how we are going to compute R subarray. And what does R subarray contains? Well, R subarray contains the number of subarrays where maximum is less than or equals to R. Okay, so let us see how many such subarrays are there in the array A. Okay, so if you look at this subarray, if you look at this array 2, 0, 11, 3 and 0, okay, so this part is something which satisfies this equation, right? Here the subarray, so if you contain this if you take this particular subarray 2 and 0, here the maximum value is less than 10, right? Less than R. So this is one such subarray, and the another such subarray would be this, right? So these are the two such subarrays which will satisfy the condition of R subarray. Okay, so once we have this, now let us see how many subarrays can be formed using these two subarrays. Okay, so let me just see. So here, if you see this, here the number of elements is 2. So the total number of subarrays which could be formed using these two elements are n into n plus 1 by 2. So this will be 3. Similarly here, the number of elements is 2. So again 2 into n plus 1 by 2. So again here is also 3. So R subarray will basically contain what is the value of R subarray? This will be equals to 3 plus 3, which is equals to 6. Okay. Similarly, let us compute L subarray. So let us compute L subarray. And what is the definition of L subarray? Well, L subarray, okay. So what is the definition of L subarray? Well, L subarray is basically will contains number of subarrays whose maximum is less than L. I'm so sorry. Whose maximum is less than L. Yes. And let us take our example. So here in that particular array, this is basically 2, 0, 11, 3 and 0. So let's just say how many such subarrays could be there. So here the array or the subarray should be less than L. And what was the value of L? L is equals to 1. Okay. So in this particular case, this is just one such subarray and this is just, right? So these are the two subarrays which are going to satisfy this, right? And since it contains only just one element, so the number of subarrays would be again n into n plus 1 by 2, right? So here the value is 1, and similarly here also n into n plus 1 by 2, so the value is 1. So again, so L subarray, what will be the value of L subarray? Well, the value of L subarray will be equals to 2. So what will be our answer? Answer is equals to R subarray minus L subarray. Okay. And what is that? Well, R subarray was 6 and this is minus 2. This is equals to 4. So 4 is what? Something we are going to return. Alright, so that's about the explanation part. Now let us look into the coding part of it. So let's jump to the coding section. So again, to begin with, we will have L end and L start, and we will set it to -1. L end and L start. So within that particular, so what do I mean by L end and L start, or R end and R start? So R end and R start is for R subarray, and L end and L start for L subarray. Okay, so let me just explain you what does L end and L start mean here. So what does this R end mean is basically, so for in order to find out the number of elements in a particular subarray. So here, so for instance, in this particular case, our R, since we are dealing with R here, so R subarray, sorry, I'm so sorry, R start is basically what? 0, right? So this is our index 0. Let me use a different ink here. Yeah, and this is our 1, right? 0, 1, 2, 3 and 4, right? So R start is 0 and R end is what? R end is 1, right? So this index. Similarly, for this particular case, our R start is what? 3 and R end is 4, right? And if you want to find out the number of elements, then the number of element here will be, is in general we can write it down it as R end minus R start plus 1, right? That is the number of elements. And similarly for L start and L end, and that is something for L subarray. Okay, so now let's go back to our coding section. So I hope L start, L end, R start and R end is clear to you, and initially the value is -1. L subarray, R subarray, right? From our explanation, I hope L and R subarray, it is clear to you. I equals to 0, so that's the iterating counter. Now, while I is less than n, this particular thing is just for counting the number of R subarrays, right? The number of subarrays whose maximum is less than or equals to R. Okay, so that is what we are doing. If it is less than or equals to R and R start is something which is invalid, so this is invalid, so we are at that time we are initializing it, right? And once this condition is not satisfied, then we are going to update our R end, and if R start and R end are valid values, right? So for R start to be a valid value, it has to be greater than or equals to 0. Similarly, for R end to be a valid value, it has to be greater than or equals to 0. Okay, if that is the case, we are going to do our n into n plus 1 divided by 2, and we are going to add it to R subarray, right? And once we have computed that, we are going to set our R start to -1 so that we can use it for next iteration, right? The same logic is for L here over here. So here, please note, this is less than L, whereas this is less than or equals to R. Okay, so in this way we'll be able to compute L subarray and R subarray. There is one more important thing which we have to note here is, while coding we have to towards the end, right? So it might be possible that we have initialized R start or L start, but we were not able to reach the end. I mean, we reached the end, and so we were not able to update our end, and that is because our the element in the array got exhausted. So in that particular case, this is an additional case which we will compute, right? See the last segment. So let me just explain it a bit more. So for instance, what I meant here is that, so the thing which I'm calculating in the last section is basically, let us say this is something which we had our R start set to 3, right? So we set our R start to 3, but R end we were not able to set because our loop got exhausted, right? So that is why towards the end we will compute this portion. Okay, so we will compute this, and once we have R subarray and L subarray, then we are going to deduct it and we will get our answer. So that's about the coding aspect of it. Now let us submit our solution. So our code got accepted. So that's about this video, folks. If you have any question or query regarding this video, please feel free to use the comment section and I will try to address them. Thank you.